Consider a convex lens L as shown in here, and here A dash represents the principal axis. Let AB be an object placed on the left side of the mirror, left side of the lens, and A dash B dash be its image. Let's see, this line or this BD represents a ray from the object. It will pass through, it is passing parallel to the principal axis, and after refraction on the lens, it will pass through the focus like this. And another ray from the point B itself passes through this optic center undeviated. Any line or any ray through the optic center of the lens passes undeviated. So these two rays meet at the point B dash, and there we get an image. Let A dash B dash be that image. Now, we usually take the distance of the object from the optic center as U, and the distance of the image from the optic center as V, and the distance of the focus from the lens as small letter f, or f represents the focal length. Now let us consider two triangles. Consider triangle BAO and triangle B dash A dash O. B dash A dash O. We know these two triangles are similar. So you can write AB by A dash B dash, that is AB divided by A dash B dash is equal to AO by A dash O. Clear? AO divided by A dash O. Let's call that as equation number 1. Similarly, consider these two triangles. Consider triangle DOF and triangle B dash A dash F. B dash A dash F. From these two triangles, you know these two triangles are also similar. So DO by A dash B dash, DO by A dash B dash is equal to OF divided by FA dash or A dash F. Again, you have this DO, the length of the DO is equal to the length of AB. So instead of DO, you can write AB by A dash B dash is equal to OF divided by A dash F. Let's call that as equation number 2. From these two equations, from equation 1 and equation 2, the left side remains the same. So clearly the right sides must be equal. So from 1 and 2, you will get AO divided by A dash O is equal to OF divided by A dash F. So that's our final expression. Now we must substitute all the values of these lengths in here. So let's look at the picture and find what AO represents. Clearly AO is the length U. Since it is on the left side of the lens, you must put a negative sign. So AO, I'm writing again in here, AO by A dash O is equal to OF divided by A dash F. So AO, this length is equal to, you have to write minus U since it is on the left side. By what about A dash O? A dash O is the V, image distance. But since it is on the right side, you don't have to write the minus sign. So by V is equal to, what about OF? OF is equal to the focal length. So F. Also it's on the right, so you don't have to put the minus sign. What about A dash F? A dash F is actually, A dash F, look at here. It's actually V minus F, or the distance O dash OA dash minus OF. So it is equal to V minus F. Now let's cross multiply these things. So minus U into V minus F is equal to Vf. So this is equal to minus UV plus U into F is UF is equal to Vf. Now take this F to the left. UF minus Vf is equal to, take this UV to the right. So plus UV. Now let's divide this whole equation. Let's call this equation number 3. Let's divide this whole equation with the equation 3 with the term UV. So this will be UF divided by UV minus VF divided by UV is equal to UV divided by UV. So this is equal to, you can cancel this U and U. Here V get cancelled. So F by V minus F divided by U is equal to 1. So F is common, so you can take that out. So 1 by V minus 1 by U is equal to 1. Taking this F to the right, 1 by V minus 1 by U is equal to 1 by F. So this is the final expression, or this is the thin lens formula. This is called thin lens formula. Clear?